Today, on how it's made. Bumpers. Lighting gels and camera filters. Steam-powered models. And candy canes. With all the attention we pay to our car's high-tech parts, it's easy to overlook the importance of a vehicle's bumpers. About 80% of car accidents are front or rear collisions. The bumper is designed to absorb the force of the impact, minimizing damage in low-speed collisions. Bumpers can be made of plastic, fiberglass, aluminum, or steel. This company makes steel bumpers. They start out as blanks, steel sheets just 0.08 of an inch thick. These are en route to becoming truck bumpers. A robot feeds each blank through a series of 7 to 9 dies, depending on the bumper model. Each die stamps the blank into a particular shape using some 2,000 tons of force. This progressively forms the blank into the final bumper shape. Both the front and rear bumpers go through the same process, only with different dies. The bumpers now travel to the next production area, where a worker clamps each one onto a specially designed cart. At this point, the factory paints certain models. These bumpers will get chrome plating. But first, they travel through a series of buffing wheels. The bumper surface must be impeccably smooth because the chrome finish magnifies even the tiniest flaws. A computer-guided crane stacks the bumpers and maneuvers them through the chrome plating process. First, it submerges the bumpers in several cleaning tanks to remove any residue left on the surface from previous operations. The company won't divulge what chemicals it uses to clean the steel, because this surface preparation is the secret to first-rate metal plating. The first plating tank applies a coat of nickel to protect the steel from corrosion. The next tank applies the chrome layer. The factory uses the standard electroplating process. In a water and chemical-filled tank, the plating metal particles get a positive charge, while a negative charge runs through the bumpers. This magnetically draws the particles onto the bumpers in an even layer. After a thorough rinse, the bumpers are inspected. Workers scrutinize the chrome mirror finish under high-intensity light. Meanwhile, this machine pressure injects molten plastic into various molds. A built-in cooling system hardens the plastic within seconds. Then, out comes the plastic components that attach to the bumpers. One of those plastic parts is the step pad that covers the top of the rear bumper. Once the pad's in place, a worker attaches a built-in trailer hitch. Steel mounting brackets help structurally reinforce the bumper. The front bumper goes down a different assembly line. A worker attaches a plastic trim that hangs down just below the bumper. Its aerodynamic shape helps direct airflow to the engine compartment. Next, 4 steel reinforcing brackets that will attach the bumper to the truck's frame. And finally, the license plate holder and fog lamps. Workers tighten all the bolts to a specified tightness. This ensures that the bumper and its mounting brackets will adequately absorb the force of the collision. Whenever a new model goes into production, the first few bumpers off the line go through a battery of tests to prove they can withstand stress, vibration, and a certain degree of what engineers call crash energy. Other types of bumper systems use a combination of springs and energy-absorbing material, such as plastic foam. With either method, the goal is for the bumper to absorb the impact. In a low-impact crash, this should ideally confine the damage to the bumper itself, leaving the headlights, the engine, and the driver unscathed. Up next, some colorful products that set the stage in a whole new light. Gels and filters can turn a bad scene into a beautiful one. They're used in theater productions to enhance the mood on stage. They're also used in film and photography to adjust color temperatures from different light sources. These lighting gels can make any scene take on a different mood. They're called gels because they used to be made of gelatin film, but today they are made out of transparent polyester. The process begins with a mix of solvent, dye, and flame-retardant chemicals. This produces a colored lacquer. A worker tests the lacquer's thickness by pouring it into a brass cup with a hole in the bottom. As the lacquer drains out of the hole, it's timed. If it flows too quickly, the lacquer is too thin, and if it drains too slowly, it's too thick. A steady flow means the lacquer mix is the perfect consistency, about as thick as engine oil. A sample of every batch undergoes this test, because the lacquer's consistency is critical. If the factory doesn't get it right, it won't bond to the clear polyester. With the lacquer prepared, workers load the polyester film into the coating machine. A big roller soaks up lacquer from a tray below and spreads it on the film. A thin bar on the roller evens the spread and scrapes off the excess. The lacquer dries in seconds. Every production run of the same color has to precisely match the last, so inspectors regularly test the lacquer's hue on swatches of clear polyester. If gel colors are even slightly mismatched, using them together will make for a patchy-looking job. Differently colored gels create different effects. This orangey red one will warm up daylight to look more like indoor lighting. Now, in a test, a gel swatch is held over a flame. The gel burns but never catches fire, proving that this batch is ready for the hot lights of a movie set. Over at another station, they're working on a different sort of color changer, a filter that goes on a camera lens. A special sheet of optical plastic is dipped in hot water and dye. The hot water opens the plastic's pores, allowing the dye to penetrate. When the plastic cools, the color will be trapped inside. The longer the plastic stays in the dye bath, the deeper the color. Some sheets only get partially dyed. They'll be turned into filters that affect only half an image's exposure. Filters made from a range of colors will help the camera's eye do what the human eye does effortlessly: adjust to different lighting conditions. The colored sheets are sheathed in thin plastic. This prevents scratching as they're cut to size. These camera filters are nearly done. All that's left is for the inkjet printer to brand them. A similar type of printer gives the lighting gels their trademark stamp. And now it's time to wrap things up. A cardboard core slides into a machine that winds the finished gel sheets onto it. Then, a pneumatic ram pushes the roll of lighting gel into a plastic bag. Now, these filters and gels are ready to show life in the best light possible. When we return, making tiny models that are a blast from the past. When factories build live steam models, they're reconstructing history. These working steam models take us on a nostalgic journey. And they're fun for hobbyists of all ages. Add a little water, light some fuel for the boiler, and it's full steam ahead for this mini replica of a 19th century road locomotive. Production starts with the boiler. A hydraulic press repeatedly punches a piece of brass, stretching the brass cap into a cylinder. It's a process called drawing, and it also strengthens the metal. A flat piece of brass is transformed into a cylinder in only a few minutes. Next, the ends of the cylinder are trimmed. Solder paste is brushed onto a brass cap and slotted into a holding device. Paste goes onto attachments inside the cylindrical boiler. Then the boiler and cap are press-fitted together. The cap boilers travel through a furnace, which melts the solder paste, fusing the caps to the cylinder. Workers polish the brass to give it a nice sheen. Then they solder copper pipes to the boiler. These pipes will expel the steam as it powers this little locomotive. Next up, trimming the flywheel, which has been precast. The flywheel will smooth out the engine's firing impulses so that it runs more evenly. The flywheel is tightly screwed to the crankshaft. Workers check the sliding action of the piston and its cylinder. Then, they attach the assembly to the engine frame and the crankshaft. Lubricating the piston assembly enhances its sliding action. Using compressed air, workers make sure the engine functions and has no leaks. Once the model passes the test, it gets its front steering mechanism. This will control the model's front wheels, while the back wheels power it forward. Steam machines are usually rear-wheel drive. A wire called the drive band transfers the energy from the flywheel to the rear wheel. The steam model is hooked up to the compressed air tank once again for a final test run. And it looks like this model is ready for some action. All it needs is a canopy to provide a little shade. A rib design is punched into a little steel roof. After it gets a nice paint job, it's attached to the model. Production on this tiny treasure is now complete. This model will also take you back in time but in high style. It's a luxury touring car. Workers install the piston cylinder assembly a little lower on this Roadster and fire it up. Each of these mini steam models is a tribute to the original and give us all a glimpse into the colorful history of transportation. Coming up, turning sugar into one of our favorite holiday treats. In the 17th century, a German choir master had some sugar sticks bent into shepherd's crooks as a special treat for his choir. And that's how the candy cane is believed to have been invented. But it wasn't until more than a century later that they earned their stripes. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.